All right, so today is really just a review. We're going to do some review problems together in class and then start working on the review that'll be tomorrow's assignment. So test is Friday over 4.5 to 4.8. So again, we're reviewing in class today. I'm going to work with you the problems that we're doing together in class, and then tomorrow it'll be a review worksheet that looks a lot like the test, and then Friday will be the test. All right, so on the test, you're going to have to graph a tangent, a sine, and a cosine, and there'll be a secant for bonus. So you can look over graphing secant with transformations if you would like to attempt the bonus question. All right, so hold on, let me move some stuff out of my way. Let's get my numbers. Okay, so to graph tangent, it doesn't really have an amplitude, but if it did, it would be 1. The period is normally 180 for tangent. Since there's nothing in there saying radian or degree, we can choose radian. So if I take that 180 and I divide by 4, that gives me 45. All right, if I take that 45 and I split it into 4 equal pieces for my increments, then I am looking at 11.25. And then my phase shift is 0 because there's no plus or minus inside those parentheses. My vertical displacement is 1, which means our midline is going to be y equals 1. There's not really a max or a min for a tangent, but we still use that idea to get our vertical stretches down. So the max would be at 1 plus 1, so 2, and the min would be at 1 minus 1, so 0. All right, so make an x-axis. Start with 0. And you need 1, 2, 3, 4, and you're adding 11.25. So this would be 11.25, this would be 22.5. This would be 33.75, and then this would be 45. All right, so the y-axis goes through 0. We have 0, 1, and 2. Our middle is at the 1. Tangent always has an asymptote straight through the middle, and the outside points are at the midline. Tangent's supposed to go up on this one and down on this one. It's a positive function, so we're going to do that. So at this second mark, we go to our max point. And the reason I say it's not a max is because we go through that point and we keep going up, but we're using that to kind of get our stretch. All right, and then over here, we're going to go down to our low point, our min. That's not really a min. And then that's what one little piece of tangent looks like. Now remember that this does go like this, and this does go like this, and you can put it or you can leave it off. It's really not that important to me. All right, so the next one, graphing a sine. All right, so amplitude is 30, and it's negative, so it's reflected. The period is usually, we're in radians, 2 pi. They are dividing by 3, so we're going to times 3. So it'll be 6 pi. The increments, we're going to take that 6 pi and divide it into 4 equal pieces, so we get 3 pi over 2. Phase shift, you take this and equal it to 0. So let's see if I can squeeze that in down here. So we're going to subtract, and we have x over 3 equals negative pi over 2. So then we times by 3. So we have x is negative 3 pi over 2. All right, so our vertical displacement is 2. So the midline is at 2. The max is at 2 plus 3, so 5. And the min is at 2 minus 3, so negative 1. All right. So let's see. We are going to have the first mark at the phase shift, so negative 3 pi over 2. Then we need 1, 2, 3, 4 more. So if we take negative 3 pi over 2 and we add 3 pi over 2, we get 0. And then add, we get another 3 pi over 2. Add, and we get 6 pi over 2, which is just 3 pi. Add to that, and you get 9 pi over 2. You can reduce or you can leave them. I'm not going to be that picky. All right, y-axis goes through 0. We need negative 1, 2 as our new middle point, and then 5 as our max. All right, so we're graphing a reflection of sine. Well, sine always starts at the middle. So the first mark gets a point on the midline. We would normally go to our max, but reflected means we're going to go down instead. So we're going to go to our min, to our middle, to our max, back to our middle, and draw a sine curve through those points. All right, I'm going to go around and check that everybody did this with me and give an assignment grade, so make sure that you are copying this down so you can send me a picture. All right, so for number 3, we have an amplitude of 3/4. We have a period, we're in degrees, so we can do 360 divided by 2. For the increments, we're going to do that 180 into 4 equal pieces, which is 45 degrees. For the phase shift, you're going to take 2x minus 45 equals 0. Add the 45, divide by the 2, and you get a phase shift of 22.5 degrees. All right, vertical displacement is 0. So the midline is y equals 0. The max is 3/4, and the min is negative 3/4. All right, so again, vertical displacement is if there's anything added or subtracted in the front or the back. So like here we had a 2, and here we had a 1. Here we don't have anything. Your max is your midline plus your amplitude, and then your midline minus your amplitude. You can't see anything that I just wrote. All right, so drawing our picture. We have a phase shift of 22.5. We need 4 more marks. We are going to count by 45, so that's going to give me 67.5. And then 112.5. And then 157.5 and a 202.5. All right, so we got to back up about half of this distance and put the y-axis. And it's going to go to 3/4 and negative 3/4. And your middle stays at 0. All right, so cosine, your first point is always at the high mark, unless it's reflected, and then it's at the low. So our first mark is the 22.5, that's our phase shift. So that's where that one goes, and then we're at the middle, then we're low, then we're at the middle, then we're high, and we get this little guy. All right, so that's our review of graphing. All right, next we are going to, if I give you the info, can you write the equation? So first of all, it says you're writing a sine function. So we know we want y equals, and we need a sine, and we need a variable. All right, so these things can go in with no work at all. Vertical displacement is the very first number. Then you do plus or minus the amplitude. That's what goes in front of sine. Vertical displacement plus or minus amplitude. All right, so get this number. You take the normal period of sine and divide by the new period, and it gives you the number that goes there. To get this information, you're going to take this 2/3 and your phase shift and multiply. But when you put it in, you're going to change the sign. So it'll be plus pi over 6. All right. So the next thing that we need to make sure that you know is, can we answer questions like this? All right. So we want to know when cosecant is 1. So think about your graphs. Honestly, that's where this is supposed to be coming from. So if you think about the cosecant graph, our cosecant graph looks like, let's see, it's a reciprocal of sine. So it has asymptotes here, and here, and here, and then over here, and over here. So this is 0, 180, 360. All right, and we know in between these we have a 1, and then here we have a negative 1. And you've got like a u that goes up, a u that goes down, and then here there's a u that goes down, and here there's a u that goes up. All right, so when is cosecant 1? Well, cosecant is 1 here and here. So this is at 90 and negative 270. All right, well, how far apart are 90 degrees and negative 270 degrees? So if you do negative 270 plus 360, you get to 90. So we know that theta is 90 degrees plus 360k, where k is an integer. All right, so thinking about our graph, we know that it happens at 90, and we know that it happens once in every 360 degree period. All right, so tangent. We know that tangent is undefined as asymptotes at 90 and 270, right? Well, undefined is where your asymptotes happen. So for tangent, we know that it happens to be undefined at 90, and those asymptotes fall every 180 degrees. All right, so when is cosine negative 1? Well, cosine we know starts at 1, at 90 at 0, it's negative 1 at 180. All right, so going back this way, we're here, we're negative 1 here, we're back, and we're here. All right, so this is 90, this is 180, negative 90, negative 180. So you see that cosine is negative 1 once in a period. So it happens at 180 degrees plus 360k. All right, so again, you got to picture your graphs or sketch them out. You just have to, for this test on Friday, remember the quadrantals. I'm not going to ask you for anything too crazy as far as can you picture your graphs and answer questions like these. Okay, just where like ones, undefined, things like that happen. So it'll be the first time it happens plus the period. All right, so here we want to find a value. All right, well, cotangent of 405. Well, first of all, let's subtract 360 from that and think of it where it's like on the unit circle or in one period of our cotangent graph. So this would be the same thing as saying cotangent of, what is that, 45 degrees? I'm almost positive that it's 45, but I would like to make sure, but I can't hit the right button on my calculator. It is. Okay, so cotangent at 45. All right, well, what I have memorized in my brain is that at 45 degrees, the ordered pair is root 2 over 2, root 2 over 2. And so either way that I do those, whether I do y over x for tangent or x over y for cotangent, I get 1. All right, so now we want to know when is secant 0. Well, thinking unit circle or thinking your graphs, whichever one you can come up with the fastest. If you're thinking the graph, then you know that secant is a reciprocal of cosine and it has a point at 1. If you're thinking unit circle, then again, you know secant is a reciprocal of cosine. So cosine at 0 degrees, the x at 0 is 1, the reciprocal of 1 is 1. All right, so Next, can we evaluate without a calculator? So again, this is, do I know my unit circle? All right, so remember cosine, we're allowed to look at the top of the circle because it had 0 to 180. So from 0 to 180, when is the x-coordinate root 3 over 2? Well, if we want it to be positive, we've got to be on this side. Remember, root 3 over 2 is the long one, so if we want a long x, we've got to be this first mark at 30 degrees. So that happens at 30 degrees. Or, because I'm pretty sure your multiple choice options on your test are in radians, you got to know that 30 degrees is pi over 6. All right, could you type this in your calculator even though it says without? Yes, because I'm not going to know the difference, but you're not going to get this. If you type it in and you're in degrees, you should get 30. But you're going to have to know that that's pi over 6 because your answer choices are in radians. All right, so when is tangent negative root 3 over 3? All right, so remember tangent is y over x. To get root 3 over 3, I had to have a root 3 on the bottom, which means I had to have 1/2 here and root 3 over 2 here, which means the ordered pair I'm looking for is root 3 over 2, 1/2. But somebody's got to be negative. Well, remember for tangent, we're only allowed to look at this part. So we've got to be positive up here, so that can't happen. Here we're positive, negative, so we're going to have a negative y. So a negative, negative, a negative, a negative. So where is that root 3 over 2, negative 1/2? Well, that's this guy right here. That's almost all the way back around. So he would be 330 degrees or 11 pi over 6. All right, again, if you put that in your calculator, what's it going to give you? So let me see. 30 divided by 30. I get negative 30. So put in my calculator, I get negative 30. Right? So I just called this 11 pi over 6. Remember, we're talking negative 90 to 90. So instead of calling that 330, I should have called it negative 30. Which means instead of calling this 11 pi over 6, I should have called it negative pi over 6. That's my fault. Completely forgot that little piece of information. All right, so if you put it in your calculator, you will get negative 30, and you just have to know what that is in radians. All right, so the next one. I don't think we've done an example like this, but there is one on the test, and we're doing one together now, and there's one on the review, and it's not difficult. So we are going to take this information and draw a triangle. So we've done something very similar to this, but it was all numbers. So this information describes a triangle. Pick somewhere to be theta. I tend to like that bottom corner. I don't know why. All right, cosine is adjacent over hypotenuse. So I know this is 2 and this is x. All right, to find tangent, I've got to know what this guy is. Right, because tangent of theta is going to be the opposite over the adjacent. So I know that the adjacent is x, so I have x on bottom. I got to figure out what the numerator is going to be. Well, if I'm trying to figure out this side right here, we'll go ahead and call it y. Then I'm going to say y squared plus x squared equals 2 squared. So y squared plus x squared equals 4. Well, to get y by itself, I have to subtract the x to the other side. So 4 minus x squared is what I have. Then we're going to take the square root. So this would be what goes on top, that ugly little expression that we just got, that square root thing. All right, so again, use this to draw a picture. You're going to have a bunch of variables, so you're just trying to figure out what this is in terms of these guys, using the Pythagorean theorem. And then you're doing tangent, so opposite over adjacent. So we just figured out that this side was 4 minus x squared instead of y. All right. So this is what we did yesterday, solving the right triangle. So we didn't do very many examples yesterday. We're going to do a couple more like one more triangle, one more word problem. All right, so they give you a triangle. These will not be labeled on the test. You have to understand that this means that that goes there and that goes there. All right, so then you are finding everything else. Well, to find this other side, I can just do Pythagorean theorem. So a squared plus 8 squared equals 10 squared. So a squared equals 10 squared minus 8 squared. So a is the square root of, what is that, 100 minus 64. But you don't even have to do that much in your head, but that was easy to do. So we're going to do the square root of 100 minus 64, which I believe is 36, so we get 6. Yes. Alright, so we know that a is 6. Alright, the other things that we need to find are the two angles. So pick one. I picked this, and again, use given information. So we have adjacent and hypotenuse, which means we're going to do cosine of A is 8 over 10. So that means the angle A is inverse cosine of 8/10, because that's how you find an angle, is do inverse cosine. So we'll do second cosine. Remember to do inverse, you do second in the trig thing, so second cosine of 8 divided by 10. And we get 36 point, if we round, to 9 degrees. So we got 36.869, so 36.9 if we round. Alright, once you know one angle, to find the other one, you're just going to subtract from 90, because if this takes away 90, then these two have to add up to 90, because the triangle adds up to 180. So I do 90 minus 36.9, I get 53.1 as angle B. Alright, so now I know everything. They gave me these two, and I found, and this. They gave me 3 things, and I found the other 3. Alright. So, a 6-meter long ladder leans against a building. So I have a building with a ladder. Alright, we assume the building makes a right angle with the ground. So it makes an angle of 60 degrees, the ladder does, with the ground. How far up the wall does the ladder reach? So we're trying to figure out this distance. How far up the wall does the ladder reach? And they told us that we are 6 meters from the bottom of the building, the ladder is. Alright, so from this angle, we know the adjacent and we're looking for the opposite. So opposite and adjacent is tangent, so we'll do tangent of 60 equals opposite over adjacent. Alright, so to solve that, we're going to multiply. So 6 times tangent of 60 will be the height of the building. And when I type that in my calculator, I get 10.4. And we are in meters. Alright, so that's a quick review. That's not everything that's on the test, but those are the things that I thought that y'all would have the most trouble with. So let me know if you have questions about any of that, and I'm going to go ahead and share the review so you can get started on it. It'll be due tomorrow evening or Friday morning, and then let me know what you want to do about taking the test if you're not going to be at school Friday.